So you can use it at the right time for what helicopter crashes also. So this was one of the location, okay, where helicopter crash took place. And recently also in the same area, another helicopter crash took place. I think some 1 month back or maybe within a month when
Within a
that
month,
thing
sir.
took place.
25.
So we developed all those terrain models for them from the available remote sensing data, and we provided them for the rescue operations. And these are few of the helicopters that you could see there. So yeah, this was the iron bridge which was there before the disaster, and this is how the whole road was actually completely, it was eroded. There were so many skulls lying all around. This is a picture photograph, historical photograph from GSI, and another is a field photograph that was taken of that particular area after the incidents. So why these incidents took place? There are so many discussions till now. It was because of the incessant rain which took place in that whole basin. That is, Dehradun received record amount of rainfall, like 595 millimeter of rainfall in 48 hours. And there was extreme event with rare combination of two active systems, namely the westerlies and southwest monsoon. Because of the intersection of these two, when rainfall resumed, what happened? There was extreme amount of rainfall, and this rainfall was the culprit because of which the whole disaster took place. So in Chorabari Tal or lake, which is located around 2 kilometers upstream of Kedarnath town, so there was a deep incision. There was a V type of incision, and that incision was around 62 to 64 millimeter. We went to field and we have measured. So that V-shaped indication overtopping followed by deep incision. So initially there was overtopping, then it was followed by the deep incision. The water level in the lake, it has risen approximately 20 meters, and lake area before breaching was around 3.4 to 3.6 hectares with length of around 320 to 160 meters wide, and total volume of water was estimated to be 7.1 into 10 to the power 5 meter cube. Okay, so these are few of the survey data which were available for that area when we went for the survey. So the average discharge was estimated to be around 1192 meter cube per second, considering the fact that the lake emptied in 5 to 10 minutes, which we got this information from the temple priest. They told that the whole lake was emptied in 5 to 10 minutes. The peak discharge is estimated as 5,376 meter cube per second by using the dam break formula given by Hunger et al. And this is the formula that we have used because this was all post-mortem studies. Okay, and this is a deep incision. If you look at this deep incision, which was around 62 to 64 meters, so this is the place from where this whole process started, and you could see one of my students who is standing there. There were similar type of incident which took place in another valley, and this was called as the Gohnatal 1894 incidents. Okay, this was called as the Gohnatal incidents from that particular Tal or lake. Tal means lake. So this Gohnatal incidents was from one spectacular lake which was developed because of landslide, which is called as Gohnatal. The devastation of 2013 or 2021, the recent one, Chamoli one, it could be compared to the devastation which took place during the 1894 disaster, which is the Gohnatal Lake Bridge flooding. The Gohnatal, it was a spectacular lake which was developed because of a huge rockfall from the right bank of Birahiganga River, a tributary of Alaknanda River, blocked in the September 1893 landslide. And the first breaching which was took place was on 25 August 1894, causing widespread inundation in downstreams. So how this damming took place? This damming took place on 6 September 1893, where two landslides took place on the right bank of the Virahi Ganga. So you can see from this picture that this scar, okay, I think many people are working on landslide here also who are using geospatial technology. So you could see how you map those landslides. You map those landslides based on tone and texture, isn't it? So you could see the tone and texture or the color and the texture of this particular image, and you can see from where the landslide took place and how the damming took place there. The side of a steep wall measuring some 1300 meters above the level of the stream crashed down into the valley, bringing large blocks of limestone that formed a dam of more than 3 kilometers wide at the base and 600 meters at the top. And height of the lake was 270 meters, and the total rock volume was estimated to be around 150 to 200 million meter cube. So here the height of the lake was around 270 meters. If you compare the Chorabarita, it was only 20 meters. So this is after the breach. When the breach took place, now how it looks like. So this is again a file picture of 1894 Gohnatal when that whole lake was present, how it looks like, and there is another picture of 2006 when that breaching took place, how it looked like. So in December 1893, the area of the lake was around 2.5 square kilometer and its depth was around 145 meters. Okay. By July 1894, the lake had become nearly 6 kilometers long. So if you compare to Chorabari, which was 320 meters multiplied by 160 meters wide. This one was how much? 6 kilometer long, not meters, 6 kilometers long and 800 meters broad. And the level of water had risen nearly 55 meters to a total of 200 meters. Okay, it went up to 200 meters. So the first breach occurred at around 11:30 at night on 25 August 1894. And at that time, the lake volume was 470 million meter cube before the first breach on 25 August 1894. During the breach, 283 million meter cube of water was released and 187 million water cube was still left there, which was partly released and lake was filled up with sediments in subsequent 78 years. Okay. So during August 1894, the drawdown from the lake was 119 meters. It means it came down up to 119 meters. So you can imagine how much water was discharged from there. And it took some 4.5 hours. Okay, it took some 4.5 hours, equivalent to average discharge of 17,479 meter cube per second. If you compare to Chorabari, it was only 1,114 or 41, something like that. And this was 17,000. So this much of discharge took place from that particular lake. At that time, the British administration, what they did, they anticipated the flood level and they created some masonry pillars at every half-mile interval. And it was placed at what? It was placed 60 meters above the ordinary flood level. Whatever the ordinary flood level was there, above 60 meters, it was placed. 8 suspension bridges were also removed. The pilgrimage road was also diverted. And then finally, there was one lieutenant who was placed there, a British soldier named Lieutenant Cruikshank, who was positioned there to keep watch on the lake. And then all these disaster mitigation policies at that time were so strong that people used what? They used at that time, the first time in Garhwal, Himalaya telegraphic connection was established and used for emergency connection. Okay. So these are few of the scenarios like the flood water hit Srinagar, which is in Garhwal, Uttarakhand. 116 kilometers downstream in 4 hours with a speed of 8 meters per second. And Srinagar, with a population of 2,000 in those days, was destroyed completely. The palace of the king, police station, Dak Bungalow, everything was destroyed, but none of the people died. Okay. Flood level at Chamoli was 49 meters. Flood level at Rudraprayag was 43 meters. Flood level at Kanprayag was 40 meters. Nandaprayag 34 meters. Srinagar 30 meters. Melakosi tragedy of 1970. Again, because of incessant rain. And it took place on 20 July 1970 when the whole Gonatal was gone, the whole water was discharged, and after that there was no further lake which was present there, and this lake vanished forever. So now this tells us what? This tells us that how exactly we should proceed with disaster mitigation policies, how exactly we should be prepared, and how exactly we should do our research in this particular field. So then comes the another question here. Like I posted so many research questions initially in my third slide. So the second question here was that how can we find out the snow cover area? How can you find out the permanent snow cover area using remote sensing? So if anyone is there from remote sensing, can you tell me what is your idea that if we want to map the permanent snow cover area, how we can do that mapping for the whole Himalaya? Anyone from remote sensing? How exactly we can do? Have you studied remote? I think you have studied remote sensing.
No.
Using? You are into introduction. Okay. What's the difference between optical and thermal remote sensing? How do you differentiate optical and thermal?
Thermal is temperature.
Okay. Can you tell me the range of optical remote sensing in terms of wavelength? What is the range of optical remote sensing?
Microfarad.
Okay, so it ranges from 0.34 micrometer and it goes up to 2.5 micrometer. This range is called as optical remote sensing. Why it is called as range of optical remote sensing? But here, because here the electromagnetic radiation or whatever we are measuring, it follows the rule of optics, and it means we are measuring what? We are measuring the reflected energy, isn't it? Basically, in optical remote sensing, we are measuring the reflected energy. Many times in exams also people confuse that optical remote sensing when it goes up to 0.7 micrometer, which is the visible range, which is wrong. It goes up to 2.5 micrometers. Okay. So what is thermal remote sensing? In case of thermal remote sensing, we are measuring the emitted energy. So here, the topic here that I'm going to discuss, we use optical remote sensing data. It means we work on the reflected energy. So if we are working on the reflected energy in spatial domain, what exactly we will do? How we can find out the snow covered area, permanent snow covered area? The theory is very, very simple. How we have theorized. The theory is very, very simple. If you have one pixel, okay, In remote sensing, every data is defined in terms of pixels. So if we have one particular pixel, if you map that particular pixel for the whole year, if you map it for the whole year, if every time that pixel is mapped and it is mapped as snow, so it means it is permanent snow. And if there is 90% snow, it means it is not permanent snow, but it is temporary snow. So we can map those 100% snow pixels, and those 100% snow pixels will tell us the permanent snow line. The theory is very simple, and which is called as the snow persistence algorithm. Basically, it is snow persistent algorithm. It means how many times there was persistent snow covered in that particular pixel. That's the basic theory. However, the processing is more complicated. It's not that simple. So snow cover extent and its characterization over the Karakoram Himalayas play a significant role in managing the water resource as well as understanding regional climate changes. However, the reliable estimation of snow cover process of the Karakoram Himalaya region faces many challenges, especially in terms of data availability. Because if you won't get covering an area of around 21,683, okay, then 8,389 and 8,947 and 2,983 for the Karakoram region, Western Himalaya, Central Himalaya, and the Eastern Himalayan regions, respectively. So all these figures, where from it came? All these figures came from the RGI boundaries. So RGI boundary is one of the boundary which is believed to be very, very correct or near to correct in terms of glacier outlines as well as glacial lake outlines. However, whenever you are using those RGI boundaries, you also need to do some amount of correction for your local level. Okay, for local level, you still need to do some amount of corrections because these are some automations and every automation has got some error. Data that we use are mostly Modi's data we have used the GLIDAS data, ERA5 land data, which is again reanalysis data. Now, if you people are working, you can also use the IMD data, reanalysis data. Have you heard about the IMD reanalysis data? Have you gone through the IMD site?
Yes, sir.
Not yet. So please go through the IMD site. You can see the IMD reanalysis data, which is available for the Indian part, and it is produced by using both remote sensing data as well as from the ground data. Okay, and further doing the modeling. So you can use that data also. Landsat 8 OLI we have used, and we have used station data also. So this is the result for Karakoram Himalaya, Western Himalaya, Central Himalaya, Eastern Himalaya. Okay. So the mapped mean and standard deviation of SCD means snow covered days, received your deviation, receiving minimum in these are months JJA, June, July, August, whereas the maximum in DJF, that is December, January, and February. So you can go through this particular paper also, which will tell you exactly that how we have actually estimated snow covered area, and we try to find out the pattern of the snow covered area annually, and we have tried to find out that how these have varied in so many years in last 20 years and how different types of variables, okay, have actually impacted the snow covered area. So what are the variables we have estimated here? We have tried to compare. So we have compared your long wave radiation, outgoing long wave radiation, incoming short wave radiation, how much amount was absorbed, okay, what is the latent heat, your other parameters. So all these parameters we have tried to combine together, and we try to find out that which factors are actually influencing the snow covered area in Himalaya, which factors are basically influencing, and because of which factor actually more your melting is taking place. So the daily cloud-free snow cover data were utilized for intra and inter-annual variability of SC over the KH region. Result demonstrated that the snow cover of the region was influenced by climatic as well as energy flux components. So both these components play a major role. And reliable estimation of snow cover variability is performed in order to understand the contribution of hydroclimatic variables. So basically, this was the paper that we have published, and this was one of the very